bit about our project, NICE, the NIMS Integrated Computational Environment. And then I'll briefly talk about the Reactor analysis tools that we've worked on. And I'll actually give you a live demonstration of those after that. And of course, here's a couple links to our wiki webpage. We have a YouTube channel with lots of videos, so you can go there. And I'll bring these up at the end of the slideshow as well. So before I really dig into what NICE is, I need to kind of address what NICE tries to solve. So in scientific computing, pretty much every user, from the most noobish user to the most advanced, experienced super user, has to do roughly these four things. And we call it the standard model of scientific computing. So the first step is you have to create some sort of input for a simulation. This input may be for an old simulation. It may be really difficult to understand, very much like ancient Mayan. It's kind of hard to decode what the simulation developers wanted you to feed as input to their simulation. You also have to know how to run the simulation on very different machine architectures. You could be running it on your laptop, you could be running it on a cluster, or you could be running it on an HPC machine like Titan, which has hundreds of thousands of cores. You also have to be able to do something with the data that comes out of that simulation. Oftentimes they produce terabytes, petabytes, and probably soon exabytes of data. And that's really hard for a single person or even a team of people to just understand right off the bat. It's mostly binary data, so we need some smart way to pull data from, pull useful data from that large data set and present that to the user in a useful way. We also have to store that data somewhere. I mean, we need to keep that data for years. Depending on the simulation codes in the US, we often are required to store it for up to like 30 or 40 years. So we have to do something with it. We can't just delete it immediately. So wouldn't it be nice if there were a nicer way to, a good program that could kind of handle each of those steps for you? So that's what NICE is. Again, it's the NIMS Integrated Computational Environment. And NIMS meaning the nuclear energy advanced modeling and simulations. So that's kind of our first major sponsor for doing our work. So with NICE, what it does is it kind of comes in between the user and running their simulations. It helps them set up the input for their simulation. It helps them launch it so they don't have to know anything about queuing jobs on exotic machines. It helps them, in some cases, analyze that output that comes from that simulation. And it also, we're trying to help the user deal with storing that data. So a little bit about how NICE works. NICE has a client and a core, and that pretty much offers you the Eclipse workbench. It gives you the OSGI services that you need to actually run NICE, and kind of sets up just the environment for you to do your analysis. So we're trying to take advantage of the full advantage of the Eclipse RCP to enable these simulation challenges, the computational science challenges. We have data structures that are devoted strictly to the more or less the model, like that's the model that contains the data that you're pulling from the simulation. And for different activities like creating the input, launching, and analyzing, we have items. So items are more or less an activity that you're doing in NICE. And a little bit more information here about NICE. It's 100% open source. Right now we're on SourceForge, but we're moving to GitHub very soon. It was developed at Oak Ridge National Laboratory by a fairly small team. We're now getting contributors from Lawrence Livermore National Lab, so it's pretty exciting. It's a growing project. We've done a lot of in-source documentation. We also have lots of UML and wiki documentation to back that up. And of course, we have lots of tests, mostly JUnit tests. So that's a little bit of background information about what NICE is, a little bit about how it's structured. So next I can get into actually what I came here to present, preventing Blinky the three-eyed fish from becoming your friendly neighborhood radioactive fish. So, keeping in mind that standard model of scientific computing, pretty much what I'm covering today is just the analysis phase and strictly for nuclear reactors. So why should we bother addressing analyzing nuclear reactors with NICE? So right now, the standard operating procedure for nuclear researchers is often just to, they have some code, they run it, and they get a bunch of data, they write their own scripts in Perl or Python, and they kind of process that data, they pull out what they want. And of course, that's a very time-consuming process. They also tend to take that data and put it and open it up in third-party applications like Visit or maybe Excel to do their graphing. So it's really an ad hoc approach to doing analysis of reactor simulations. Ideally, they would just be able to run that simulation very easily, pull out the data immediately for their analysis, and to be able to browse it intuitively, pull out whatever they want to know very quickly. They should be able to also compare it with some sort of reference data, make sure that their simulation works well very quickly, immediately. And they should also be able to, if necessary, extend the available data analysis operations. For instance, if you want to run a clustering algorithm or look for anomalies in the data, that should be something that, if it's not there, you should be able to implement yourself and then contribute it back to the other researchers. So with that in mind, the goals of nuclear reactor analysis in NICE, we want to make it very simple to use. We want to make it standard, so everyone should not have their own way of doing things. There should be one very well explored way of doing things. And we also need to make it powerful. So how did we do this? So one of the first problem we kind of came across was that a lot of different simulation codes write output in totally different ways. They all have their own way of doing things. So the first thing we did was to kind of adopt the HDF format for storing reactor data, and we developed a C++ and Java library to enable the simulation code developers and users to kind of port their data to a standardized format. And of course, we take advantage of the hierarchical structure of reactors and kind of mirror that in the data files too. So they're very simple HDF files. We also developed several domain-specific reactor views to kind of make it easy to browse the data and kind of narrow down what you're looking at. So this is kind of what I'm showing. In this case, these are SFR, so they're sodium cooled fast reactors. They're a new reactor design they technically don't exist right now, but they're kind of researching those actively. So what we want to do with NICE in the reactor analysis is kind of give the user an easy way to start up from the top level, the reactor, move down to the assembly from the reactor, and then move down to the fuel rods, fuel pins, guide tubes, instrument tubes inside the assembly. We also wanted to enable a sort of visual comparative analysis. So you should be able to take that data from the simulation, plot it next to each other for your simulation data, and also for some sort of validated reference. But that's not quite enough. We also want to enable quantitative comparative analysis. So we should be able to take the two data sets and compare them. We should do the math for the user so they don't have to take it, put it in Excel, and run their own computations on it, or even develop their own shell scripts. That's a really big problem that nuclear researchers are kind of dealing with right now. So keeping all of those ideas in mind, I'm going to get to an actual demonstration. If I can find my mouse pointer, here we go. So this is NICE. It's a very standard Eclipse RCP application. We have in the top right our editor workspace. That's where all of the useful graphics are being displayed. We have a little console that can feed back information to the user. And we have these list views and tree views that we use to kind of help the user go through their analysis to create items. And again, we've actually made several changes to the Reactor Analyzer since the last EclipseCon. So before, you kind of had to understand that everything in NICE is an item. So an item being just a process that you're doing in computational science. So you would have to go into NICE and actually create an item. So to create a Reactor Analyzer, you would press that green plus button, pick a Reactor Analyzer, and then it pops up with some kind of useful view. Before, we also had this view so that you could actually, we had drop downs that let you select what files were being associated with this Reactor Analyzer view, but we thought it was better to kind of maximize the screen real estate. There's no need for there to be, unnecessary drop downs there for users to have to kind of wonder about what they do. So we started to take advantage of perspectives. So we have this new reactors perspective, and we kind of get rid of the whole idea of items. So now you don't have to worry about what an item is. You just think, I'm analyzing a reactor. So in the top left, we have this reactor viewer. It's actually a tree viewer, and to load reactor files, you just go over to it. You have an action up here, but of course, not everyone likes to look for buttons on toolbars, so there's always a right-click menu. So I can open up any available reactor data files that I have. To actually associate those files with, oh, that's interesting. Yay, bug number 1. Okay, I must have broken that one last night. It's okay, I've got one that works. Just bear with me here. So of course, this is Murphy's Law striking yet again. It'll just take a second for NICE to come back up. But anyway, this is kind of a problem that we've been dealing with a lot recently. So we've had several iterations of the Reactor Analyzer. First, we had one that used tab pages, and of course, that's a very SWT based. It wasn't really, didn't really fit in with the rest of Eclipse RCP appearance or anything like that. Then we started switching to having these editors. And we actually originally had a big sash form, so you have 2 different views of a reactor, but we decided to get away with that because what you want to do is to have as much of the screen real estate as possible dedicated to analyzing a particular reactor. Of course, because we're using RCP, you can actually you can still do that side-by-side analysis by just taking advantage of, you can drag one editor and place it on the side of the screen. I'll do that in a moment. So anyway, let me load up those files again. So these are all HDF5 files. Oh, did I not click? Okay, well that is very interesting. I've never seen that before. So I did not expect to get such a bad bug that kind of stops everything, but I can kind of just briefly go over some of the features we've included. So since last time, we've developed this 3D plant view, and I can actually show you a picture of that. I came somewhat prepared in case catastrophe struck. So one of the last projects we kind of had to do was this. I think this is gonna, why did it put it on the other screen? Okay. Apparently my Windows skills kind of suck. So anyway, So we developed this JME3 based, Java MonkeyEngine 3 based plant view. Good grief. I'm sorry, folks. Okay. See if we can expand this a little bit. Okay. So we have this plant view. So before we just had reactors and assemblies in reactors and pins in assemblies, but we were kind of tasked with increasing the scope a little bit. We've had some people doing research into actual flow through the plant. So we developed this 3D plant view of a reactor. So what you're seeing here is kind of, you've got all these little light blue pipes, and that's where the fluids or waters go through. You've got these dark blue things are heat exchangers. So what happens with heat exchangers is you've got these hot fluids that are coming from the reactor, and they're going through and heating up the water that's inside the heat exchanger. That water turns into steam, and that's how you power a steam engine. In the middle is kind of a cutaway view of a reactor core. So eventually we'll have it so that you can kind of embed reactors inside this plant view. So you just click on that reactor, and then you can kind of narrow it down from there. But right now it's kind of separate from the core views.
Or simulating?
I'm sorry, what was the question?
Does this view show live reactors, at least in production, or is it only simulation of what would happen?
So at the moment, it's mostly a simulation. The people we are working with have a very mathematical model that they've kind of developed into a simulation package. I can't really tell you much more than that, partly because I'm not really an expert in their stuff. But they kind of had a similar interface, but it was using a Python GUI, Qt GUI, and they kind of wanted us to pull in a similar kind of feature into NICE so that they could start using our interface to do their simulation stuff. I mean, the thing that they were doing is that they were mostly researchers. They're not really UI guys at all. So they wound up spending a lot of time kind of maintaining this Qt GUI. So they kind of tasked us with, say, hey, can you help us make these plant views? And of course, I can't rotate it right now because, you know, it's just a slideshow, but it is a fully interactive. There are ways to actually update it through the interface. So you can create your own kind of reactor plant from scratch. And that's actually what I did to generate this picture. So we also have these, so I can't really show you the light water reactor stuff because obviously NICE kind of bugged out really badly on me. But in any case, we have, right now we support light water reactors and sodium cold fast reactors. So light water fast reactors are very standard these days. They're very rectangular based. Basically, you've got this giant box with a whole bunch of assemblies in it, and those assemblies contain rows and rows and rows of fuel rods, and they're about 13 feet to several meters tall. And so they're the very common types of nuclear reactors we have these days, but we're also researching sodium cold fast reactors. So one of the challenges that we faced developing the views for light water reactors and sodium cold fast reactors was how do we kind of reuse the code to generate these square versus hexagonal grids. So originally for the light water reactors, what we did was we just used SWT and a grid layout, and it worked well for light water reactors. But then we had to kind of adapt that to hexagons. Obviously, when you take a bunch of hexagons and put them in rows and columns and you don't pack them together, it looks hideous, and also it doesn't even match the structure of sodium cold fast reactors. So what we did in this case was we kind of abstracted the process of laying out these reactor components into a grid and developed a very GEF-based MVC style setup. So I can actually show you a slide on that. Oops, wrong application. So I'll go ahead and skip to this part. So this is a very standard GEF model view controller. So our model are basically, we consider different views to be grids with cells, and it's a very, very basic view. Our views are cell figures, and we have, for the grids, we have root figures that basically contain a custom grid layout. With that custom grid layout, what you can do is you basically assign a cell to that grid, and you just give it an index. You give it a position within that grid. So then the grid layout automatically computes where that should be placed in the graphics. And of course, each cell figure has its own grid data associated with it. Our controller are, of course, standard GEF edit parts. The really cool thing about this approach is that we made the default behavior that square grids, like this light water reactor assembly here. To actually get these hexagonal and circular and packed kind of layouts, we only had to extend a few classes. We only had to extend grid edit part factory a few times, grid edit parts just a couple, and sometimes we only needed to just implement our own, or subclass the cell edit parts. So it's a really flexible way that we came up with to kind of address these domain-specific and even reactor-specific views. And I can kind of briefly tell you a little bit about what you're seeing here, since I can't really show you in nice. So I guess it's not a very nice day for me. So you have this light water reactor assembly. Normally it's a full view. It's a 17 by 17, so it has 17 rows and 17 columns of fuel rods. And in practice, often the data is calculated across the length of the pins. So think of this, you have this giant block of fuel rods, and they're all just layered next to each other. And when you're running your simulation, it usually computes data for a mesh across that. So there's a 3D mesh, and it computes so many points along the length of that assembly and the lengths of the rods. So what we decided to do was to take that assembly and kind of split it up into segments. So in this case, I think we had 49 segments, and that was actually a request from the researchers at Oak Ridge. And what you're looking at here is a data view of the top right quadrant of the fuel assembly. So what basically, we've taken that assembly and laid it on its side and just kind of sliced it, and you can look at different levels of the data by kind of scrolling through by using a slider. So basically, there's a little slider over here next to the view that you just drag up and down, and that pulls you through the different data. And you see the values updating, the colors change. So that's actually really handy whenever you're doing visual analysis of the reactor. So for instance, in this case, if you see like a blue data point inside the middle, and that means something's up with your simulation. So we really wanted to enable and facilitate quick, eyeball tests. So I'll just go ahead and go on to another kind of challenge that we tried to address. So not everyone likes to interact with systems the same way. Of course, I kind of mentioned this before. Some people like toolbar buttons. Some people like context menus that pop up. So how did we kind of solve this problem? So before, of course, we used SWT, creating menus and menu items, adding listeners to things, and that was really tedious, to say the least. And so we decided, why can't we just use JFace? Why can't we use JFace Actions specifically? So the problem with JFace Actions is you still have to create them. You still have to implement the run method, for instance. And what we decided to do was to actually reuse those actions for all of the, the context menus, for the toolbars and the drop downs. So to do this, we developed this structure called action trees. And basically, an action tree is just a tree of JFace actions. It actually wraps the actions to create basically a tree of actions. If you want to have like a drop down in a toolbar or a submenu in a menu, then you would create an action tree and just pass it a text. So you pass it the title of whatever you want to call that menu. And then what you would do to kind of fill out that menu is to create several more action trees and add those as children to that first action tree. So once you do that, all you have to do is just call the action tree and tell it to add its contribution item to the toolbar manager or menu manager, and then boom, you've got this really nice submenu that has custom actions for each item. And in this case, for these SFR core view, this is kind of showing a couple of options for selecting the different type of assembly that you're looking at. So in this case, we really took advantage of the action tree. So in this case, we have 5 different types of assemblies, and these are all specified in an enumeration in our code. And the really cool thing about action trees is that all you do is you create one tree, you pass in assembly type as a string, then you loop over the values of the enum, and as you loop, you basically take the value, create a new action, and add it as a child to that assembly type action tree. And then you add the root node to the menu manager, and you've got it. So it's a really quick way to kind of create full menus of items in just a few lines of code. I'm not sure exactly how many lines we reduced it from, but we reduced it to about, maybe 12 lines tops for this menu. So I'm kind of impressed with that myself. That was kind of exciting, one of those exciting moments when you're programming and it just works. In NICE, we also wanted to make extensible analysis tools. So basically, if you're missing some sort of algorithm you want to run on your data, then it should be easy to kind of make your own. So we provided these interfaces for doing that. We have an analysis tool, which the Reactor Analyzer has its own analysis tool, a KDD, knowledge discovery algorithm. And it basically takes the Reactor data and compares it through subtraction and doing percentages and so forth. It uses iAnalysis documents to kind of contain that data. And the way that you kind of pull that data so that an iAnalysis document and an iAnalysis tool can use it is you have idata providers. So data providers are basically, it's like a tree provider provides nodes for a tree in JFace, tree content provider, I'm sorry. You basically, a data provider can produce contains lots of different idata objects. And idata objects are actually the core. These are the values, they have uncertainty associated with them. So back in that grid view, you're basically looking at the fuel assembly being its idata provider, and all of these different data points being individual idata. So there's a lot going on with NICE. Of course, if you want to see more and if you want to see demos of NICE actually working, I recommend you go to our wiki page, and we've got lots of YouTube videos you can watch. And of course, you can come by afterward and I can try to figure out what's going on. It's not really my normal working laptop, by the way. It's the US government wouldn't allow me to kind of bring my working laptop here, so they gave me a junky Windows machine. I'm a Fedora guy, by the way. So as far as what's going on in the future, we're of course always improving the core capabilities. For simulating, we are working on producing real-time updates as you simulate. So basically, you're getting information about the simulation as it happens. We're adding a new plugin for plotting. And that kind of goes in line with the new support that we're adding for the visit visualization tool. And that's actually the picture you can see over there. That's a prototype that we developed several months ago. And it's actually kind of been incorporated into NICE, but there are a couple issues with Visit that are being worked out right now, so I can't really show that to you live. Another important news, UT Patel, which is ORNL's management company, joined the Eclipse Foundation, which is great. And we submitted a proposal with NICE as the initial contribution. As far as I know, it's en route to becoming Eclipse ICE. So that's really cool. And along with that, we're moving to Eclipse 4. So that's kind of exciting new stuff. So here I promised there would be links at the end and QR codes, of course. If you have any questions, you can go to our wiki. You can contact me or Jay by email. You know, I really recommend you watch the YouTube videos because they're really helpful. We're constantly putting out new YouTube videos every month or two. And that's it. Any questions? All right. Thank you very much.